This is the Earth, and the Earth is covered by a thick layer of gases that we call the atmosphere. The atmosphere is made up of zillions of air molecules that have weight and are constantly in some sort of motion. The weight of these molecules upon a unit area of the Earth's surface is called atmospheric pressure. So, exactly what is the amount of pressure exerted by the atmosphere? At mean sea level, the pressure exerted by the atmosphere is exactly equal to the pressure exerted by a column of mercury that is 76 centimeters in height. We can calculate this pressure using the formula P equals to H rho G. Considering that the density of mercury is 13,590 kg per meter cube and the acceleration due to gravity is 9.81 meters per second square, we find that the pressure exerted by the atmosphere is equal to 1013625 pascals. That is an enormous amount of pressure. Although Pascal is the SI unit of pressure, we also use a number of other units to express atmospheric pressure. The pressure exerted by the atmosphere at mean sea level is equal to 1 bar. Since 1 bar is equal to 1013625 pascals, the atmospheric pressure is equal to 1013.625 millibars. Atmospheric pressure can also be expressed as centimeters of mercury. At mean sea level, the pressure exerted by the atmosphere is equal to 76 centimeters of mercury. Each millimeter of mercury is also called a torr. Hence, the atmospheric pressure at mean sea level is equal to 760 torr. All this while, we have been talking about the atmospheric pressure at mean sea level. However, as we gain altitude, the density of air decreases, and therefore the atmospheric pressure also decreases. This graph shows the variation of atmospheric pressure with altitude. This relationship between atmospheric pressure and altitude is used in an instrument called the altimeter, which is the device that is used to tell the altitude in a plane that is flying in the atmosphere. Even at the same altitude, atmospheric pressure is not equal at all places. At places where the temperature is high, the atmospheric pressure is low. This is because with rising temperature, air molecules move farther apart. This causes a decrease in the density of air, thereby resulting in a reduction of atmospheric pressure. Atmospheric pressure is found to be typically low at places that are humid. This is because moist air weighs lesser than dry air and hence exerts lesser pressure. The variation in atmospheric pressure at different places results in some interesting observations about weather. When air is hot and humid, it becomes lighter and rises, creating a low pressure upon the land. When this moist air reaches higher altitudes where the temperature is low, it condenses to form clouds. Hence, low pressure areas are associated with cloudy skies. Conversely, when air is cool and dry, it becomes heavy and sinks, creating a high pressure upon the land. This sinking air is heated up by conduction, and hence its moisture carrying capacity increases. This results in clear skies over high pressure areas. What's more, the air that sinks in high pressure areas spreads out and moves to low pressure areas. This movement of air on the Earth's surface is called wind. But we also see the effects of atmospheric pressure beyond weather observations. For example, can you see the role of atmospheric pressure in these observations? And now, the summary of this video. The weight of the atmosphere per unit area of the Earth's surface is called atmospheric pressure. At mean sea level, atmospheric pressure is equal to 1013625 pascals or 1013.625 millibars. Atmospheric pressure can also be expressed in centimeters of mercury or torr. Atmospheric pressure decreases with rising altitude, temperature, and humidity. Low pressure is associated with cloudy skies, whereas high pressure is associated with clear skies. So that's all in this video. In the next video, we will begin with a new chapter called Upthrust and Archimedes' Principle.